This is the introduction video for the Flowrate measurement lab. In this lab, you will use 3 different techniques to measure the flow rate through the blower system that you were introduced to during the pressure measurement lab earlier in the quarter. After you've made your measurements and done some unit conversions, you will compare the results from these 3 different techniques. Before we begin, I'll review the operation of the blower unit that you saw during lab number 2. At the start of the lab, your TA will turn on the blower using the same panel that was used for the pressure measurement lab. The speed will then remain held at the same nominal value throughout the duration of the lab. Remember, in this lab we're trying to compare among 3 different flow rate measurement techniques. So we want the speed to remain the same during all of our measurements. The first way you'll measure flow rate in this lab is using a Merriam laminar flow element. The laminar flow element consists of an array of bundled tubes up here in this housing just after the intake to the blower. What we'll do is we'll measure pressure drop across this bundle of tubes through which there should be laminar flow, and then we'll use a calibration curve in order to relate that pressure drop to the flow rate through the bundled tubes. That pressure drop, in addition to depending on the flow rate, also depends on the temperature and the atmospheric pressure, because these change the density of the air. And so you'll have to apply correction factors, which you can find in the manual for the laminar flow element. You should measure temperature in the room using any thermometer. The thermometer, in this case on the manometer connected to the laminar flow element, will work fine. And you should measure atmospheric pressure using the digital pressure gauge, which you used during the pressure measurement lab. The ASME nozzle is located here inside of the measurement cell. There are several pressure taps located near the ASME nozzle. Part of your task in this lab will be to determine which pressure taps to use in order to measure the pressure drop across the nozzle. You can measure the pressure at any of these taps using this manometer, which you were introduced to during the pressure measurement lab. The pitot tube is located at the end of the flow cell. You can measure the stagnation and static pressures using the well comparison manometer. You should be sure to get the pitot tube aligned perfectly in the direction of the flow in order to get a good measurement of the stagnation pressure. Over the course of the lab, what you might notice is that the pressure, as measured across the Merriam laminar flow element, tends to wander over time. This means that the flow rate through our test section is also wandering over time. And so what this means for your measurements is that you should try to take the raw data for your measurements as closely together as possible. So because there are a lot of units conversions involved in this lab, and a lot of calculations to do after you've taken your measurements, what you should do is take measurements for the laminar flow element, for the ASME nozzle, and for the pitot tube all at once, and then, after those measurements have been made, go to the board and try to figure out what the flow rates were for each of those different measurement techniques. So measure first, then do units conversion in order to get the best results in this lab. That's all for the flow rate measurement lab. By the end of this lab, you should be able to describe several different techniques for measuring flow rate. Again, if you have any questions, just ask your TA, and thanks for watching.